Oh, what is that for? Don't know. Okay, here we go. Perfect squares, perfect cubes. So the idea here of perfect squares, 7 times 7, is the area. So the area is side squared. And usually you write that as s squared, but I wrote the word side, so you know that's s and not a 5. So for our question, the area would be 7 squared, which equals 49. Okay. If I want to know the side length, that would equal the square root of the area. So if I have 49 as the area, which equals 7 squared, then what does 7 equal? Well, it equals square root 49. But square root 49, we can write a different way. How else can we write 49? 7 times 7. Okay. So what we have is we have two equivalent values. The value of 7 equals square root 7 times 7. All right. So if a square is an area of 64, what would be the side length? Well, side length would equal square root 64. And how can we also rearrange that? 64 would equal what? What two numbers are the same multiplied to 64? John? Yeah, 8 times 8. So we're saying the 8 equals the side length. Now I'm going to write the word side just so that you don't think it's a 5. Okay. Volume is the same way, except volume equals the side length cubed. Okay. So volume equals 5 cubed, which is 5 times 5 times 5, 125. Okay. So we could say 5 equals the cube root of what? 125. Which is like saying 5 equals the cube root of 5 times 5 times 5. So one thing to keep in mind here, this 3, we call that our index. The index of 3 means inside we must have 3. Do you guys know what the index is here? We never write it. 2. Okay, it's an index of 2. And that's why we have to have 2 8s. Why did it do that? It's doing that all morning. I tried that, but then it starts erasing more stuff. Really weird. It's never done that before. Okay, so this equals 8. So 8 times 8 equals 8. And 5 equals cube root 125. Cube root 5 times 5 times 5. Okay, so if we have 6, and we're going to use index of 4, what do we have to have on the inside to have a value of 6? How do we get the left side and the right side to be the same? Look at your index. Exactly. So if we have 4 of them, then we can take out a single value of 6. Okay. So we're going to be working on this over 2 days. All right. Okay. Square root 400. Okay. Let's take 400. What can you break that into? Can you break that into 2 numbers? They're identical. Yeah, it equals 20 times 20. Okay. So that simply equals 20. Now, what can you break 20 and 20 into? Did it again. What the heck? 20 times 20. What can you break 20 into? 4 times 5 times 4 times 5. Okay. So if you take that out, that equals 4 times 5, which equals 20. Right? We're looking for, you okay?
I don't know. I think I have a nail in my throat.
Oh.
I bit my nail.
Oh, do you get a drink of water if you need to, Riley? Go ahead. Just go if you need to. You just look joking there.
I'll do it.
Okay, if you need to go, just get up and go, all right? Okay, what we can also do is break the 4s down. So the 4s can break down into 2 times 2 times 5 times 2 times 2 times 5. If we want to take them out, we would have 2 times 5 times 2, which equals 20. Now what we're going to do to help us, when we have to simplify these, we're going to look for pairs. Looking for pairs. Okay. So, you don't want to write this part down. You don't have to. Just watch and enjoy. We can divide by 2, and we get 200. Divide by 2, we get 100. Divide by 2, we get 50. Divide by 2, we get 25. Divide by 5, we get 5. That's what we did yesterday, isn't it? Right? We found the prime factors. Now we have to look for pairs. And that's because we have a 2 that we don't write. So here's a pair. I can take out a 2. Here's a pair. I can take out a 2. And here's a pair. I can take out a 5. So I get 2 times 2 times 5. Just a different order. Okay. It's just really different. A lot of you haven't seen this before. I'm going to lose it. Why is it doing that? Okay, let's do 64. Divide that by 2. What do we get? Divide by 2. Divide by 2. Divide by 2. Divide by 2. Okay. What does the index tell us to look for? Pairs. So here's a pair. We can take out a single 2. Here's a pair, single 2. Here's a pair, take out a single 2. So square root 64 equals 2 times 2 times 2. Multiply them together, 8. Okay. Now another way of writing this, and you don't have to write this down, so we can say square root 64 equals 1 square root 1, 2, 3, 4, 5, 6. Right? That's these red 2's right here. Okay, all of them, multiply them together, will equal square root 64. So that equals 2 times 2 times 2, because we're looking for the pairs. Okay, so I'm just showing you the same thing in different way. Same thing, different way. Hannah. Yeah, totally, 2 cubed. But then we want to go to a simple number. Okay. All right. Okay, let's try this one here, number 3, square root 64. So we already did this, but I want you to take 64 and divide by 2. So I want you to do prime factorization. Okay, so do your prime factorization. Go, do that now. What are we looking for clusters of? Okay, we're looking for triples or groups of 3. Okay. So here's a group of 3. You can take out a 2. Here's a group of 3. You can take out a 2. So cube root 64 equals 2 times 2, or 2 squared, which equals 4. Okay. 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 And again, we're going to do some more of this tomorrow, okay? So don't be too concerned. You're like, what? Okay. So next one. The index is 6 now. Now we've already done this division twice here. Do you guys want to do it one more time? I know I don't. So I'm just going to write 2 times 2 times 2 times 2 times 2 times 2. Right? You've already done it twice. So you're just taking your division and write it down. So what does that equal? Exactly. You can only take out a single value of 2 because the index is 6. Okay. What's the next one? 144. I want you to write that a different way. Write it as 1 multiplication. What would it be? Hornsberger?
12 times 12.
Bingo. How many people got that? Good. So what does that equal? 12. Right? Square root 12 times 12. Good. What I want you to do now is break down 12. So now you're going to have 4 numbers. So break down the front into 2 things that multiply together, and break down the back. Good. So what can we take out? Yeah, you can take out a 3 times a 4, and then that equals 12. All right, let's have some fun. Break that down even further. 3 times something, 3 times something. Yep.
3 times 2 times 2.
Yeah. And at the back?
3 times 2.
Exactly. And so then you're going to get what? Which equals? Good. See the pattern that we're doing here? How far do we have to break it down? So now what I want you to do, oh, that's unbelievable. Take 144 divided by 2. So I want you to do your division this way, please. So you'll notice the numbers we got right here were exactly the same as the set we finished with. Okay? It's just a different way of organizing your work. Okay. Any questions? Let's practice this a bit more. Okay. So we can also go the other direction. Write 6 as a perfect square. So 6 equals what? 6 times 6. Right? Write 4 as a perfect cube. What goes on the inside? How many? 3 of them. Good. Okay, we're trying to make this connection with the cube root and what must go inside. So 6 with an index of 5. So this must be a 5 right there. How many do you need, Rylan? What's your index?
Oh,
Yeah.
um,
You need to have 5 of them. Whoops. In order to keep the same value, you must have 5 of them. Okay, and your index sign, this is a big boo-boo right here. You must cover all of the inside. So you must extend your line so it covers everything. Otherwise, it's considered outside your square root sign. Okay, so make them nice and long. You need a roof over their head. Any questions? Okay, so we're jumping around a little bit. Negatives, watch the index. Okay, this is an odd index. And so what we have is what 3 numbers multiplied to -8 that are the same? -2 times -2 times -2. And so the value is -2. Okay. So with an odd index, you can solve the negative sign or the negatives. Okay. But let's compare that here where we have an even index of 2. What 2 numbers multiply to -4 that are identical? Alex? Incorrect. Because -2 times -2 equals +4. Right? So we need a -4. Interesting. Think about that for a second. Hello, Vice Principal Sloboda. I'm doing well, thank you so much. No, I have my prep. I have a block. I have that class right now. Yep. Not that I know of. So this block B right now is when I have my grade 10 math class. Yeah. No worries. Thank you. Bye. Wait. So what do you guys think? Yep. Hornsberger.
-2 times 2.
-2 times 2. That's exactly what it must be. Are those identical? No. So this DNE. Do you know what DNE stands for? Does not exist. You can't take the square root of a negative number. Or you can use circle with a line through it, which means does not exist. This is called null set. You'll be using null set a fair amount this course, so write it down. Alex, don't just stare at it, write it down. Okay, so null set does not exist. Right? Even the 6th root of -20 does not exist. Even the 8th root of -400 does not exist because those are even indexes. You can't take an even index with a negative sign. Any questions? Okay, turn it over. So we're going to go back again to what we were doing earlier. Square root 121, how can you rewrite it? 11 times. So what does that equal? Good. What about 196? Do you guys know that one? Because I don't. So let's take 196, divide by 2. What is that? 98. Divide by 2 again. 29. 49. Divide by 2. Sorry, divide by 2. What am I thinking? It's not even. Divide by 7. Okay. So this equals 2 times 2 times 7 times 7. You don't need to rewrite it, but I did just so you can see what can you take out. 2 times 7, which equals 14. So if you didn't want to rewrite it, you could just circle it, show me you're taking out a 2, circle it, show me you're taking out a 7. Okay, there's two different types of work there. You guys okay with that? Thumbs up, down, in the middle. Okay. All right. We do more of this tomorrow, some more practice. Well, this one, 512. Divide by 2. 256. Divide by 2. 128. Divide by 2. Can you finish it off? Oh, it's a long one, isn't it? So you could. Why did I circle 3 of them? Good, the index is 3. We're looking for triples. Awesome. Take out a 2. Take out a 2. Take out a 2. Now, if you wanted to rewrite it, you're welcome to rewrite it. So if you rewrote it, that's what it would look like, and then you could circle or underline your triples. Okay. So I showed my work 2 different ways. Any questions? Okay, try next one, 4th root of 81. I think you want to divide by 3 to start. Try and use your calculator as little as possible. Sometimes you need a head start on it, and that's fine. But once you get down to easier numbers, don't, because there is a non-calc section on the test, right? Good. 750, I'd start by dividing by 5. Is that right? That's not right.
No, because the first one's supposed to equal 150.
Ah, thanks. No, that's not right. Ooh, this is weird. Is this right? Double check. What do you guys think with this? What can we take out? We take out a 5, and what then has to stay behind? That's right. The 2 times the 3 don't make a triple, so they stay behind. And what should we leave it as? 2 times 3, put those together. 6. Right, so it's called 5 cube root 6. And we'll be doing some of that, a lot of that tomorrow. So you won't get any decimal answers when you do Pythagoras anymore. You're going to get exact answers. Okay, that's going to be what we're looking at tomorrow. Okay, I think you guys are pretty good, so let's not do the last one, but let's go on from here. Here's some applications. A square has an area of 324 centimeters squared. What is the length of the side? And then what is the volume? So let's start by saying area equals s squared and substitute in what we know. Do we know the value of s? Not at all. We know the area is 324. That equals s squared. What's the opposite of squaring? Square rooting. So you did a lot of this with Pythagoras. You'll have s equals square root 324. Please do that on your calculator right now. You ever shove a calculator out and try this? If not, come up and get a calculator because we've entered the calculator section. Come up, grab a calculator. Anyone need one? Matthew, you got one? Okay. You need one? Come on up. You can kick off your shoe. I just need your shoe. You need a shoe? I give you a calculator. That's the deal. Thanks. You won't walk away with my calculator. Okay. No, just kick it off. Just leave it right there. Yeah, perfect. Thank you. Okay. So what does it equal? 18. So if you have an old school calculator like mine, you go 324, hit your square root button, voila, answer pops up. If you have a new calculator like a graphing calculator, if you press the square root button, which for me I have to hit second function. Right there. See how I have a square root button? A square root sign? That means I have a newer calculator. If I hit 324, that takes the square root of it. But I should be really careful and make sure I put brackets around it so it doesn't take square root of anything else. Okay. Press enter, 18. Okay, so that's what the side length is. Now that we know the side length, we can find the volume. The volume is s cubed. So it's going to be 18 cubed. So you should know how to do cube, and you should use this button here that can do anything cubed. 5,832. I did say that right? Yeah. Okay. With a new calculator like a graphing one, you want to hit the little hat button. Sometimes you have a little hat button. So this would be 18 clear. 18 exponent 3 enter. 5832. Who needs help with their calculators? Anyone? Okay, we're going to do more of this later and you will need help. Alright? So that's the volume and that'll be centimeters cubed. There we go. So now we're going the other opposite. Now we're going to start with the volume. That equals the side length cubed. So 1728 is the volume. That equals s cubed. How do we get rid of the cube part? What's the opposite? Cube root. So we have to cube root both sides to keep it equal. And we're left with the side length equals cube root 1728. Make sure you cover up all the digits. Okay, cover up all the digits. Go ahead, use your calculator. For an older calculator, 1728. And then I have to go cube root 3 equals 12. For a newer calculator, like a graphing calculator, I got to get cube root first. And I'm looking for it. I think I have to go math, don't I? Yep. So I'll go cube root, which is 4. And cube root what? 1728. Put my bracket in, press enter, 12. Okay. And now I find the surface area of a cube. How many squares are on a cube? How many sides are there on a dice? 6. So there's 6 squares. 6 times s squared. So that equals 6 times 12 squared. So 12 squared is easy. 864. Okay. All right. So let's do this one first. For the new calculators, for question 3, you have to enter 5, hit this x square root button, then press 2765, then press equals. If you have an old calculator, you hit 2765, this button, then 5, then equals. Okay. All right. I'm going to break the answers up, see if you get them. You got to know how to use your calculator because this question's super easy. For yours, it's a new one. Okay. Any others, if it's a new or old? Yep. Is it graphing? Okay, so you got to go to math. So if you look at this and press math, it's right here, number 5. But, hold on, Angela. You have to make sure you press 5 first because that means 5 is where the x is. Yeah. And then you hit the 5 again to bring up that sign. And then you can put the inside in. When you're all done, yes. You might need some help, okay? Let me get the answers first, and then I'll take all calculators. Okay, so I have the answers. Please try them all. If you don't get one of them, come up right away. Once you've got them all, then you can start on your homework, okay, which is listed on your unit outline.